Okay, we are doing the second stream of the day. We are doing the electronics project with Arduino. I did some preparation ahead of time to test out some of the components as well as to clean up my circuit board from last time. And hopefully that will lead to less grind this time. Let me get my windows to the right spots. This goes here, and then we need the YouTube up. Yeah, for anyone who is tuning in from the previous stream, this one tends to be a little bit more chill. The goal today is to show off the device known as a potentiometer. A potentiometer is a voltage. And that's a lot of fancy words to say that it's a fancy knob. So let me see if I can pull out the potentiometer right now, just to show you guys what it is and how we will be using it today. Alex, hello, welcome back, Surprise Pika. And we are live. Thank you, Stream Elements. So today we're gonna be playing around with this little guy. This is, well, it's a blue knob, but at the bottom of it, we've got three, well, if the camera stops zooming in randomly, it's got three prongs to it, and I will draw some diagrams to show how it works. But basically, this is a variable resistor. A resistor will resist the flow of electricity, and a variable resistor will have different values for how resistive it is. I've heard like the best description for what a resistor is and what it does is that it's a really bad wire. Like a wire is supposed to conduct, electricity, right? So a resistor is a wire that conducts electricity but doesn't conduct it very well. Let me go over to the desktop. And let me get let's get the chat over here. Okay, cool. So last couple of weeks we talked about having, well, that's a tiny little pen. Let's go to the big pen. So last week we talked about how for most electrical circuits we have a high voltage, so like maybe 5 volts, and then we have a low voltage, which is like 0 volts. And this is a relative measure, so it's 5 volts above 0 volts. Higher voltage has more electrons. The higher voltage wire has more electrons stuck behind it than the low voltage side. Low voltage also has electrons, but just less than high electrons. Between the high and the low, there is a load. So this thing that I've drawn here, this is the load. And the load dissipates energy as the electrons flow from the high side to the low side. And of course, you need a battery in order to maintain this same pressure differential in the electrons. So this is kind of your basic circuit. So a resistor is something that turns electrical energy into heat. It inputs electrons and outputs electrons, but it outputs less energetic electrons. And all that energy is, let me just switch to the red, for greater immersion. It dissipates as heat. And in the case of a light bulb, it's not heat, it's photons. Technically photons are also heat, but it's infrared heat. It's infrared photons, whereas your normal light bulb will be visible spectrum photons. Anyway, so this thing, it will dissipate heat. And today we are going to be using a very special kind of resistor that dissipates heat. So Ohm's law says, what does Ohm's law say? Voltage is current times resistance, right? So here we got voltage. Voltage is about 5 volts. 5 is equal to whatever the current is and whatever the resistance is. So if we have, I tested out this variable resistor, i.e. potentiometer, and today's potentiometer is going to be 1 kilo ohm, 1 kilo ohm, 1 KO, 1 hit KO. No, 1 kilo ohm, which is 1,000 ohms. Ohms is spelled like OHM. And 1 kilo ohm is not a lot, but it's useful for our purposes. So essentially we're saying 5 is equal to something times 1000, right? Because we have 1000, 1k, 1000 ohms. So the current here is going to be, if you do the math, 5 divided by 1000, that's what, like 2 milliamps. Is that right? Did I do the math wrong? No, that's definitely wrong. Scuff math nerd. Is it 5 divided 5 1 over 200? No, it's 5. Is it 5? I'm gonna just type in a Google calculator. I can't talk and math at the same time. My brain can only do so many things at the same time. So 5 divided by 1000. That is 0.5. 0.005. Okay, so it's 0.005 amps. And then that's the same thing as 5 milliamps, right? So 1000 ohms, 5 milliamps is 5 volts. That is the basic math for this diagram. And this is all good, but what if we want something like 3 volts? We have 5 volts, that's good. But what if we want 3 volts? So if you look at this diagram, like if up here is 5 volts and down here is 0 volts, then like intuitively you can infer that like maybe 1 volt is here, 2 volts is here, 3 volts is here, 4 volts is here, right? If this were like a linear chart. But it's not a linear chart and we only have one resistor. So on one side of the resistor, it's still 5, the other side of it is 0. So how do we get like 3? Because it's like kind of in the middle, right? It's somewhere in between this and this. So like, what if we drew like a little dot right here? Like if we just had like a voltmeter, we had a voltmeter and then we just pointed it in the middle of a resistor. Well, we only have one resistor, so we can't really do that. But if we had 2 resistors, it gets kind of funky, because if we have 2 resistors, so here's, we're still in red, but if we have 2 resistors and then we have another resistor here, and then this is 1k ohm, 1k ohm, and then another 1k ohm here, right? It should be pretty easy to wire up. Then in the middle, you can kind of infer that just by intuition that this should be 2.5 volts, right? It's like kind of in the middle. And we can like do the math for this diagram as well. So like between these two, this is, you put 1 and 1 together, you get a 2k ohm resistor, right? So if this weren't 2 separate resistors, and you were just measuring between up here and then measuring between down here, this would be 0, this would be 5, and then in between, this is equivalent to a 2k ohm, right? So we can do the math here, and then if we have a 2k ohm resistor, it would be 5 is equal to something times 2k ohm. And that something in the middle should be what, like 2.5 milliamps? Did I do that right? Probably. So if we have 2.5 milliamps of current within this one wire, and let me make sure that I actually did that math right. 5 divided by 2000. 2.5, yeah, exactly 2.5 milliamps. Then we can take this current. So this current is 2.5. And then we can find the voltage just across the first resistor. So let's do the math here. 1k ohm times 2.5k milliamps is how many volts? Well, it's 2.5 volts, which lines up with our intuition that halfway across the diagram, it should be halfway across the voltage. So that's how you do math for these series resistors. And they're series resistors because they line up in a series, right? Like it's one after the other. The alternative is a parallel wiring scheme. So this is a parallel wiring scheme where instead of doing one resistor after the other resistor, the electrons can flow through the first or the second route. And this is in parallel because they run in parallel. But we're just looking at series today, and in between, it's going to be the ratio between the first and the second resistor. So in between the voltage in between the resistors is a function of sorry, brain just farted for a bit. The voltage in between resistors is a function of the ratio between the values of the resistors. So here is 2.5 because these two are equivalent. Okay, so this is all good. But what is a potentiometer and why are we using it? So a potentiometer is a variable resistor. So instead of having two resistors in a series, what we actually have is one resistor and then another resistor. And then these two resistors' values are controlled by a knob, by a KNOB, by a knob. So you might have a total of like 10k ohm resistor for the whole potentiometer, and then between the between the top and the bottom, you might have it distributed like 2k and then 8k if you turn the knob like counterclockwise. And if you turn the knob clockwise, you might get something like 8k versus 10k, 8k versus 2k. So you can adjust the resistance of each individual component, not independently, but like you can adjust them so that their ratio changes. And then in between, when you have this wire, this value will change depending on what these values are, right? So as you turn the knob, this voltage will change. So that is kind of useful because now you have a knob and then you can input a linear transition of values. But why is that helpful for our LED mask project? I finally ask after 24 minutes of monologuing. Why is this at all related to what we are doing here with the Arduino? Well, so we are doing lights showing up for the mask, and one of the ways that I would like for the light to show up is depending on the volume of my voice. So I might want a mode where the louder that I speak, the brighter the lights get, or the louder that I speak, the more lights show up. So we need a way of controlling the lights based on some input value from a microphone. I do not have a microphone for this Arduino yet. I just bought it on Amazon. It's still coming in the mail. I'm a scuff streamer because I don't prepare my materials ahead of time. So instead of playing around with a microphone today, we are playing around with something that also has an input and output. Or at least we have an input or output. Alex says, is electrical engineering your career, or have you learned all of these through interest? I majored in computer science, and I do software. I'm scuff at hardware, but I know the basics. I took some classes when I was in college all those years ago, where I learned the basics of how a lot of this works, but I've never put it into practice, like into a project before. This is the first time. Poggers, that is so cool. Thank you, Alex. And I hope like you guys will join along with me on this journey of learning as well, because like right before these streams, I will spend time to go and do research on what I should stream, and it can't be too hard because I suck at this as well. And it can't be too easy because otherwise there's no content for the stream. So tonight's goal is we are going to have this little knob control the LED strips that we hooked up last week. So last week, if you guys remember, we made this LED roll light up, and we were very excited for that. But the wiring was a little bit difficult. It didn't need to be difficult. I just wired it wrong multiple times. And I cleaned up the wiring quite a bit before the stream today. And then let's see if we can make these light up just like we did last week, even with new wiring. So a couple of things for me to set up. First is on the desktop. Just as a refresher, what did we do last week? So last week we did the WS2818B, and that's a lot of letters and numbers, but it's just the sequencing for the type of LEDs I'm working with. This is a very common type of LED strip. You can cut it up, and then it pretty much has 3 inputs. 5-volt ground, and then it has data, and that's it, and you just wire it up very easily. And then this is the diagram that we used last week in order to wire up the Arduino. So the first thing that I want to do today is just to make sure that I've continued to maintain the correct wiring. So I got my Arduino here. Pin number 7 on the digital side is going to row number like 40 something on the let me turn on the lights so I can actually see, because these are very tiny numbers. But pin number 7 is going to row number 55. I'm gonna move the microphone a little bit closer just because I know it's a new microphone and I haven't gotten used to using it yet. Number 55, and then that's hopped across by resistor, and then that goes over to the 330 ohm resistor, and that goes over to the data in for the LED strip. And then we've got black and red wires going into our 5-volt power supply. Let me bring out my 5-volt power supply. It is rather large and heavy and cumbersome. Okay, so got our 5-volt power supply just like last week. Let me get some of this water out of the way. And I do need to use the bathroom relatively soon again, because I'm a well-hydrated boy. Okay, that looks good. And then where are my wires and cables for this? So I got the power supply. This goes to the scanner. What am I? For the stream. I know my voice is also off on the side. I'll be right back while I plug this in. So the power supply is plugged in on one end. Okay. And let's see how that shows up on side cam. So red goes into red. Get the microphone a little bit closer. And then the black goes into the black, probably. There's also a green. I don't know in what kind of circumstances you want to use the green, but usually that's for like earth ground. Which is just another lead for the thing underneath your foot and how many electrons that thing has, i.e. that planet, the planet. That's a topic for another day, is how we got the name ground. But we got red into black into black, and then orange into red, just to power our little circuit so far. So I'm repeating the work that we did for the last VOD, which you guys can find in my Twitch archives or on my Discord. And I plan on putting it on YouTube as well at some point. And let's see if I'm gonna fry my Arduino right now by turning on this power button. Press button. Okay. Well, things are happening. So for anyone who missed the last stream, this value here is the voltage. The second value here is the current, just like we looked at earlier. It says A instead of I for amps instead of current, which is I for some reason. I don't know why it's I. But it looks like it's doing what it did last week, which is that it's switching between colors for the first couple of... Well, you can't see that in the camera. Let me zoom it back a little bit because I crop out the bottom section of my camera. So it's switching colors, which is the program that we loaded up from the last stream, which means my circuit is at least good and I don't smell anything burning. So I don't think I've lost any electrical components yet. My Stream Deck is now a little bit far away for me to reach, but let me go and fire up the code that we ran last time. We just downloaded this code off of some example set, and we modified it just a little bit. Let's see. I think that was, where was it? Arduino. But yeah, for anyone who is in chat, I'm very curious how you guys found my stream. And also, if you guys are doing similar projects yourself at home, like I find that these types of obscure solid state electronics projects, they're kind of like Legos, right? Like, you know where I came from. Yeah, I know where you're from, or you know where we met, at least Alex. And thank you for following on my stream. I hope I'm providing somewhat entertainment value, or at least chill value, for you while you're doing your homework, or I'm not sure how busy school is. Man, yeah, I remember being in school. It was a very stressful time. But I don't know, like after you graduate, it just, and you're back in the real world, and you got real world problems that you're solving with the skills that you learned in school. It's very rewarding. Things like this, but you know, maybe a little bit more productive than just making lights show up. Oh, I need to use the bathroom. I will be right back. Where's the BRB screen? Okay, I am back. By the way, I like the college experience, but don't enjoy the homework and exams. Yeah, that was always the... Yeah, homework is always one of those things where I feel like it's kind of like lazy teaching. Because if you've taught someone correctly, you're not necessarily giving them just knowledge. You're also giving them interest, right? Like if you teach someone something and you're teaching a subject, and the only reason that your students have for being in your class is because they need to pass exams that gives them a good grade, whether it's for GPA or for grades, it's kind of like you're giving them the wrong incentive to learn, because like it's so focused on what you know and how well you do on the exams, as opposed to like building genuine interest. That is a lot more valuable than doing well on exams, because genuine interest means that I'm just gonna move these leads a little bit further away from each other so I don't short my power supply. Once you have genuine interest, then you have a whole lifetime of knowledge, because you're interested and you can always find more knowledge. Yeah, exactly. Some people learn better when there's less pressure. Yeah, and like people learn better when they actually want to learn. Like motivation is a lot more important than like exam scores. And I'm a big fan of not teaching people stuff that they don't care about either. Like I don't think everyone should take every class, especially in high school. There's a lot of like required classes that aren't fundamental. I get that math, geometry, all of that stuff is important, especially statistics, but like I don't know. There were definitely classes that I took in high school that I've never used in terms of the knowledge from there. It helped. I have some that like built interest. Like now I'm really interested in history, but um, I don't know how helpful it was for me to take like a ceramics class. You're trying to cram all this information and rush the students, and the goal should not be to learn, but to try and get it done as fast as possible. Exactly. It becomes more of a question of doing as opposed to a question of learning, because like when you're in real life, what might be the reason that you will want to learn how to fix a car? Well, you'd only want to learn how to fix a car if your car is broken, right? Um, if you don't have that proper motivation for needing to know and being able to benefit from that knowledge, then that knowledge is just moot. And you're just intentionally making someone suffer. Like knowing is good, but not everyone needs to know everything, and that's true in real life as well. Okay, philosophy aside, back to the project. I am glad that it's still running the old program from previously. Previously, we wrote a loop for affecting these colors on the camera. Hopefully, it shows. Let's zoom back just a little bit. Hopefully, it shows the colors changing for some of the bulbs, and then the bulbs are spaced like 10 bulbs apart for which ones are lit and which ones are not lit. As the kids say. And previously we wrote this little program to change the colors. I believe this loop gets called 100,000 times a second or something crazy like that. So on every iteration of the loop, we are setting the first light bulb to some color, then the 10th light bulb, as well as the 20th light bulb to some color. And then the color is dependent on this variable that we call time. So like as time goes up, the RGB values for the color also goes up. So we did this last time. We also said that once the time gets to like above a certain value or below a certain value, then just reverse it. I actually probably want this to be 4. Otherwise it jumps a little bit. And I'm just gonna press the upload to make sure that everything is properly connected, which it's not because I didn't actually plug in the USB cable from the Arduino to my computer, which I will do right now. A lot of words to say something very simple. Okay. Not the cable. Oh, it's one of these days I'm gonna have to show you guys my PC, because it is a project that I worked very hard on, and it is very, at least to me, it's very aesthetically pleasing. But that will be a demo for another day. Okay, so I actually plugged in the cable this time, unlike my Papega past. Let's go and verify it. Okay, and let's upload, make sure we can upload. Said a bunch of things. Arduino, blah, blah, blah. Sketch uses some, I think it actually uploaded correctly. And I fixed the bug from last time, which is that once time gets to like 3, it'll go to -1, which is why we get that flashing last time. Oh my goodness, that is very bright colors. For the LED strips, it kind of hurts my eyes a little bit. The camera isn't pointing at the right project. Oh, it's just randomly zooming into things again. This Papega camera, I probably need to replace it. But it zooms into random stuff all the time. Okay, so this is working. What we are doing today, though, is something new. Today we are doing a potentiometer. So let me go and look up the tutorial for this. Arduino, they call it a analog read serial. Analog read serial. Basically on the Arduino board, there are, let me see if I can find a better, yeah, okay. On the Arduino board, there are basically a bunch of holes that you can plug into, and these are signals that you can send out. The digital pins are for sending digital signals, and those are either 0 or 5 volts all the time, and you're just sending like these highs and lows, and the timing and the sequencing between the highs and lows is what determines the data that's sent. Analog, on the other hand, there are 6 analog ports for Arduino, and analog, on the other hand, it's not just 0 or 5 volts, it's between 0 and 5 volts. And if it's like 2.3 volts, you can read that as a value from the Arduino board. And that's more of a function of the instantaneous voltage difference between ground and the analog in. So it's an instantaneous measurement as opposed to a time-based digital signal that's coming in through one of the digital pins. For our purposes, it's not super important that all of those physics terms are being described, as long as we can use it to light up our LEDs, because the colors are what we care about at the end. All right, so we got our potentiometer. Let me go back to the camera. Yeah, my Stream Deck is being blocked by this power supply now. I think I can give it some extra space. Okay, that feels a lot more comfortable. So the potentiometer here has 3 little leads, and according to our diagram from MS Paint, we also have 3 little leads. So we just need to hook up one to the high, one to the low, and then the value in the middle we will read on the Arduino side. So I'm gonna go ahead and plug this into the breadboard. I already have everything wired. This goes into row number 20. 25, 26, 27. And now I can twist this in order to send different signals. But first, let's see if we can read the signals from the Arduino side. I haven't tested this snippet of code, so things might take some debugging. But according to this diagram, you just send 5 volts ground, and then you need 1 data for going into the analog in, and that's exactly what I have here, is complete with the blue wire. Let me make sure. Yeah, okay, it should be correctly. Yep, that's going into analog in 0. So what do we do now? According to the documentation, it says planned maintenance window on April 16th. I am not very interested. Schematic, we've wired it up exactly the way that it's supposed to. In the code below, the only thing that you need to do for setup is begin serial communications at 9600 baud between your board and your computer with the method. I think this is for reading out. And then in order to read the analog, you just say analog read, and then you give it the pin number. Okay, so let's take a look at this code. I have not tried running this yet. File, let's create a new. All right, let's see what is in the setup. The setup says set up the serial communication at 9600 baud. I'm not sure why we need serial, because this is all analog. But after we read the value, I think we do need to print it out somewhere. And for the board to talk back to my computer, I think it needs serial. So the tutorial is asking us to set it at 9600 baud, and this just means that for sending digital signals back to the computer, it needs to be sending it at 9600. I believe it's 9600 like up and downs, 9600 waves per second. Is the timing that they're using in order to send the signal. It's kind of like a channel. It's on channel number 9600. The loop routine runs over and over again forever, and then the loop says to read the analog signal, which will be varied by our potentiometer. Let me drink some water real quick, just because it's been a while and I've been talking a lot. So read the analog signal, store it into the sensor value variable, and then print it out into the serial. Okay, so it says the serial monitor is in the Arduino software, and I can open it by clicking on the icon that looks like a lens on the right. Lens on the right. Ah, okay, so there's a button on the top right of the corner. It's a serial monitor. I'm gonna click it, and it gave me a new window. Okay, so I got this like very blank looking window. It says COM3 at the very top. And on the bottom, there's a very small drop down for the baud rate, and I have it set to 9600 baud, which coincides with the settings here. So we should be able to see the results of the serial print line here. What else does the tutorial say? It says, okay, you can see a steady stream of numbers ranging from 0 to 1024. Okay, so let's go and upload this and see what happens. It's set to use the pin A0, which indeed is what I have set on the board. And I have the potentiometer to adjust this somewhere in the middle of its range. And let me triple check that everything is incorrectly. Okay, well, let's just go and upload this code and see what happens. And before we do that, we need to save it. I'm gonna call it, I'm gonna save it to documents. Where is Arduino? Arduino, and then I will call this potentiometer. Okay. So I uploaded, and now the serial. Nice. Okay, cool. So the serial console is printing out numbers that's around 512, which is very much expected because I adjusted the potentiometer to be exactly halfway between min and max. And according to the documentation, the value that you read should be between 0 and 1023. And 512 is right in smack dab in the middle of 0 and 1023. I'm going to twist this a little bit. I'm going to twist it counterclockwise and see how that value changes. Counterclockwise makes the number bigger. Hopefully that's visible on stream. Yeah, okay. So now it's at about 600 instead of 500. And I'm going to max it all the way up. And it is around 1023, 1022, which is the max value. And if I turn this potentiometer down, the voltage drops, and therefore the value being read is dropped. It's down to about 100 now, from 1024 down to 100, and I've turned it to the minimum it can be, and it's giving me numbers like 10 and 9. A lot of very useless values that I don't need to look at all the time, but I think it's overflowing my buffer now. Let me see how much RAM this is using on my computer. Oh my goodness, I am running out of RAM because of this program, I think. Am I? No, Genshin Impact is still running. Genshin Impact, let's go and close that. Okay, so we got all of our RAM back. And things are less laggy now. Okay, cool. But we still don't need all of this output. So I'm going to stop Genshin eating that much. Yeah, it was eating about 4 gigabytes of RAM, but don't worry, I have 128 gigabytes of RAM on this computer. Where's my specky? So it will be a cold day in hell when I ran out of resources for this computer. Anyway, how do I stop this thing from running anymore? Maybe I can just close. Okay, I just closed it. I also, maybe I'll just comment out this serial print line, because we don't actually even want to print it out anymore, and I'm just gonna go and upload it. Yep, 128. I went all out when I was building this computer. I have a Ryzen 5950X with 16 cores, clocked to I think 4.5. For the CPU, I have a GTX 3080, and I have 128 gigabytes of RAM. So, if nothing else on the internet, at least I can use this to brag and to flex on people. Whenever they insult my mother over in multiplayer games, I can tell them that at least I have 128 gigabytes of RAM. But yes, where were we? So we can read the value, but can we use the value to make our lights differently colored? So my goal is to twist the knob and have the colors change. So we've read the sensor value, but we need to set the sensor value into the color that we had earlier for the RGB lights. So let's get the code again for our LEDs. If I upload this, you can see that it just changes the color, but it changes the color according to time. It changes color according to time. I don't know what else to say about that. And we want the colors to change based on how much I twist the knob instead. So let me go and grab the example code from the potentiometer. And we don't need to use serial, because serial was only used for printing out values into our computer. We only need the analog read. So this will give us a number between 0 and 1024, 1023. And by the way, for those of you guys who don't do computer science on a regular basis and you're wondering like, what's with all these random arbitrary numbers? Like, why is it between 0 and 1023? Let me get my MS Paint out again. So, okay, make this bigger. So why is it between 0 and 1023? What's with these fancy numbers? 1023 is 1024 plus 1. Okay, well, what's so special about 1024? 1024 is 2 to the 10th power. And this is a very useful calculation because everything in computers is done by 2. Because binary is useful. And 2 to the 10th power is a very useful value to have because humans, at least people who grew up in westernized countries, we like the number 10. We got 10 fingers, we got 10 toes. And in order to track large numbers, all we have to do is raise it to the power of 10. Or have it raised to a base or to a power of 10. So you can have $100 bills by doing 10 to the 2nd power. And that's how like 0 comes around, right? Like it's a Babylonian Arabic numeral. 10's a very useful number. But 2 is not, because we might be looking at a number like 256. And you just kind of got to remember it as like 2 to the power of 8. But 2 to the power of 10th is a very useful number because it's almost 1,000. It's almost 1,000. It's not exactly 1,000, but it's almost 1,000. Which means if you need to do some of these calculations with exponentials and you have like 2 to the power of 20 and then you're like, I don't know what that is, you can say it's like, oh, it's just something like 1,000 times 1,000. Because there's 20 of them in here and each 10 of them is 1,000, so 20 of them is 1,000,000. It's not exactly 1,000,000, but it is pretty close to 1,000,000. And that's very useful because like a lot of times you're doing calculations and then you're like, what's 2 to the 48th power? Well, it's 2 to the 40th power times 2 to the 8th power. And then if you remember all of 2's powers below 10, you'll know that 2 to the 8th power is 256. And then what's 2 to the 40th power? Well, it's roughly 1,000,000 million, right? You just count the number of commas, and then that's the prefix for the 10, because there's 4, and then you have 4 commas, right? So it's 256 trillion. That's a really easy way of doing math around powers of 2. So 1024 is a valuable number. By the way, fun fact from computer science, a kilobyte is not a kilobyte. What do I mean by that? Well, if you have like 1 kilobyte of data, like you buy a flash drive and you have 1 kilobyte of data, very tiny flash drive, that is not 1024 bytes. That is 1,000 bytes, because kilo means 1,000, right? Like you have a kilogram, that's 1,000 grams. When you buy a 1 kilobyte flash drive, you actually get 1,000 bytes. This is This is a nice round number, but it's not a 1024 bytes. Well, what do you call a 1024 bytes? It's actually called a kibi byte. Kibi byte. Kibi byte. And it's usually abbreviated as KIB as opposed to just KB. So when you go and download like a megabyte of data, you're actually downloading a mebibyte of data and not 1 million bytes. You're actually downloading 1024 times 1024 bytes as opposed to 1 million. And this is a different number. This is more of like academic, whatchamacallit, pretentiousness to like actually call things kibibytes or mebibytes. Like we never use it. We never use that word at work. We always just call it like a terabyte or a gigabyte. We never call it a tibibyte nor a gibibyte. But that would be the actual scientific correct term way to describe these numbers. Anyway, so we are going to be changing the code so that the potentiometer can go and adjust the colors for our LED lights. It's currently running this program, and we're still gonna go and modify the 1st, the 10th, and the 20th light bulb in our roll. Let me see. Okay, cool. I am not as scuffed of a streamer as I was last week, and I did remember to switch scenes. Okay, and back to back to the code. So instead of using time as the variable to determine the color, let's use the value that we read from the analog input, and let's just call it color. And it's just going to be a number between 0 and 2 to the 10th power. We'll initiate it as int color starts off at 0, and then we'll read it from the analog, and then we'll set the color of the LEDs to be something like whatever we read, the voltage divided by 4. So let me go and set that for all the values. So it's going to be the color divided by 4 for red and for green, and that's going to be for the first light. And let me see if I can make this a little bit bigger, because I remember watching my own VOD, and then the text didn't render very well in the VOD. And then we're going to set it for the green and the blue mix for the second one, and then we're going to do it for the red and the blue for the third mix. So all of them should be different colors, but all the colors should be dependent on what we've set the potentiometer to, and we don't need this code for modifying time. So let's go and upload this, and let's just see what happens, because a lot of times the best way to learn is to fail, and it's no use trying to get things right the first time. Okay, so let's go to the camera. Site cam. Yep. Okay, so we've got some colors on this roll. Okay, and it looks like it's blinking on the camera, and it looks like it's blinking in real life as well. Okay. Let me remove this bit of tape so I can unroll this LED strip. Okay, right. So we got 3. Well, kind of got 3. Huh, I wonder why it's like squinting so much. Oh, it's reading the values off the potentiometer for the brightness. Okay, so if I turn this knob, it should affect the brightness. Okay, so I've turned the knob all the way up, and it is indeed getting way brighter. And let me go and turn it down a little bit. By the way, the camera is flashing on stream, and that is because the camera's filming rate is different from my living room's light sources. I have Philips Hue bulbs, and those probably run at 50 hertz or probably variable hertz. Whoa, that camera really likes to zoom in, huh? I promise you guys, I have no control of that. You guys see my hands. I'm not controlling this camera. So the lights above me are flashing at like 120 times a second, or probably 100 times a second, and whereas this camera is capturing at like 30 frames per second, so every once in a while it might flash. But I am adjusting the knob so that it sends bigger and bigger values to the program, and then now I'm adjusting it down so it sends smaller and smaller values. It's still like flashing quite a bit, and that's probably just because of noise from the potentiometer. Like, this is not a perfect knob. It'll send very different resistance depending on how I'm like just adjusting the wires around it. Yeah, I bet if I tap it hard enough, it would affect the colors. So I didn't actually want it to affect the brightness. I wanted to affect the colors themselves. So I'm gonna need to change the math here a little bit. Because I want it to change the hue, not the brightness of the values. So how will we do that math? Right now it's giving us a number between 0 and 256. And we need to mix it. I believe if we turn one color brighter and then the other color dimmer, then that should affect the hue. So what if we did 256 minus the color? Okay, that should make one component color, RGB, brighter while the other one gets dimmer. 256 minus, and that should change the actual hue of the color as opposed to the brightness. Go and upload that. And indeed, the colors are different. And what if we go and twist this knob? Ooh, now that's an interesting result. As I twist this knob, it changes the hue of the color as well, which is exactly what we wanted. So that is our desired effect for the day. I wasn't sure if this was going to work. I've done the parts... I've looked up the tutorials ahead of time, but I haven't actually tried the circuit. And I am glad that it is able to do what I wanted to do today. Poggers. I am also very poggers right now. That has been my whole mood for the evening is poggers. So I think I will end the stream on this note of success. Next stream, I think once I get my microphone in the mail, and some interesting facts about microphones as well. Once I get my microphone in the mail, I will plug it into the circuit board, and let's see if I can get the colors to change from the sound of my voice, at least on in this prototype. So I'm gonna end the stream right now. Let's see if we can find someone to raid. As always, I stream on Wednesdays and Saturdays. Usually I stream Genshin, but recently I've taken to stream Valheim as well. And then every Saturday at 10 p.m. I will be doing this project. All right, man, good night. Thank you for tuning in, Alex, and I hope you enjoy the content, and I hope you also have a wonderful evening. And hope to see you at the same time next week as well. But let's see if we can find someone to raid with our viewer count. In the technology channel, technology, science and technology. Let me go over to the desktop to browse. 24/7 Twitch statistics. Ooh, what's this? Control my Anki vector robot. You can type commands to... Oh my goodness, this looks very interesting. You can type commands in order to affect a robot. Can we try hello? Vector. Hello. I do have one of these myself as well. They're very fun. Make sure you see its face. Does it work? Oh, beep bop. Beep bop. Hello, Chop Soy Zero. Oh, Well, I feel so welcome. Okay, let's go and raid this channel. Vector the robot. That has been a lot of fun hanging out with you guys, but of course, we are human. Humans need to sleep, and hopefully you guys have some fun with this other technology channel. Start raid. If you guys enjoyed the content tonight, please make sure that you are followed so you know when I'm going live. I do keep my Twitch schedule up to date. And besides that, I have a Discord in my profile. Anything else? Yeah, same bad time, same bad week next week. I will see